thing on now? I've been working long like a marathon now. Tying up words, making them a bomb now. Tell me, who turned on the alarm now? I got a message when they put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Yeah, turn it up. We got the power. Come on, is everybody with me? It's time to get together, no more enemies. Throw your hands up, can you feel the energy? Yeah, come on, can you finally hear what this means? 40-something years been chasing down this street, running like a wild man, going since 15. Yeah, we're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Woo. Yeah, get it turned up. We got the power. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We're feeling inside, yeah. We're touching the lightning, we're coming alive, yeah. We got the power. We got the power. Yeah, let's go now. We got the power. Let's get it. We got the power. Tell me, is this thing on now? I've been working long like a marathon now. Tying up words, making them a bomb now. Tell me, who turned on the alarm now? I got a message when they put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Yeah, turn it up. We got the power. Come on, is everybody with me? It's time to get together, no more enemies. Throw your hands up, can you feel the energy? Yeah, come on, can you finally hear what this means? along like a marathon now. Tying up words, making them a bomb now. Tell me, who turned on the alarm now? I got a message when they put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Yeah, turn it up. We got the power. Come on, is everybody with me? It's time to get together, no more enemies. Throw your hands up, can you feel the energy? Yeah, come on, can you finally hear what this means? 20-something years been chasing down this street, running like a wild man, going since 15. Yeah, we're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Woo. Yeah, get it turned up. We got the power. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We're feeling inside, yeah. We're touching the lightning, we're coming alive, yeah. We got the power. We got the power. Yeah, let's go now. We got the power. Let's get it. We got the power. Tell me, is this thing on now? I've been working long like a marathon now. Tying up words, making them a bomb now. Tell me, who turned on the alarm now? I got a message when they put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Yeah, turn it up. We got the power. Come on, is everybody with me? It's time to get together, no more enemies. Throw your hands up, can you feel the energy? Yeah, come on, can you finally hear what this means? 20-something years been chasing down this street, running like a wild man, going since 15. Yeah, we're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Woo. Yeah, get it turned up. walking long like a marathon now. Tying up words, making them a bomb now. Tell me, who turned on the alarm now? I got a message when they put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Yeah, turn it up. We got the power. Come on, is everybody with me? It's time to get together, no more enemies. Throw your hands up, can you feel the energy? Yeah, come on, can you finally hear what this means? 20-something years been chasing down this street, running like a wild man, going since 15. Yeah, we're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Woo. Yeah, get it turned up. We got the power. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We're feeling inside, yeah. We're touching the lightning, we're coming alive, yeah. We got the power. We got the power. Yeah, let's go now. We got the power. Let's get it. We got the power. Tell me, is this thing on now? I've been working long like a marathon now. Tying up words, making them a bomb now. Tell me, who turned on the alarm now? I got a message when they put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Yeah, turn it up. We got the marathon now. Tying up words, making them a bomb now. Tell me, who turned on the alarm now? I got a message when they put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We feel it inside, yeah. We got the power. Yeah, come on. We got the power. Yeah, turn it up. We got the power. Come on, is everybody with me? It's time to get together, no more enemies. Throw your hands up, can you feel the energy? Yeah, come on, can you finally hear what this means? 20-something years been chasing down this street, running like a wild man, going since 15. Yeah, we're touching the lightning, we're coming alive, yeah. We feel it inside, yeah. We got the power. Yeah, come on. We got the power. Woo. Yeah, get it turned up. We got the power. We're touching the lightning, we're coming alive, yeah. We feel it inside, yeah. We feel it inside, yeah. We're touching the lightning, we're coming alive, yeah. We got the power. We got the power. Yeah, let's go now. We got the power. Let's get it. We got the power. Tell me, is this thing on now? I've been working long like a marathon now. Tying up words, making them a bomb now. Tell me, who turned on the alarm now? I got a message when they put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We feel it inside, yeah. We got the power. Yeah, come on. We got the power. Yeah, turn it up. We got the power. Come on, is everybody with me? It's time to get together, no more enemies. Throw your hands up, can you feel the energy? Yeah, come on, can you finally hear what this means? 20-something years been chasing down this street, running like a wild man, going since 15. Yeah, we're touching the lightning, we're coming alive, yeah. We feel it inside, yeah. We got the power. Yeah, come on. We got the power. Woo. Yeah, get it turned up. been working long like a marathon now. Tying up words, making them a ball now. Tell me, who turned on the alarm now? I got a message, we didn't put it in a song now. I'll see you later, all the haters got it wrong now. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Yeah, turn it up. We got the power. Come on, is everybody with me? It's time to get together, no more enemies. Throw your hands up, can you feel the energy? Yeah, come on, can you finally hear what this means? 20-something years been chasing down this street, running like a wild man, going since 15. Yeah, we're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We got the power. Yeah, come on. We got the power. Woo. Yeah, get it turned up. We got the power. We're touching the lightning, we're coming alive, yeah. We're feeling inside, yeah. We're feeling inside, yeah. We're touching the lightning, we're coming alive, yeah. We got the power. We got the power. Yeah, let's go now. We got the power. Let's get it. We got the power.
Sorry about that, folks. My audio was muted. I managed to. You'd think that, like, however many sessions in we are, I would have the hang of this right now, but apparently there was still a ball that could be dropped, and I managed it at the very end. So my apologies. Now, hello to everybody. Today's session is the finale, I guess, where we're going to be covering technical art inside of Unreal Engine. Now I'm going to be running through a couple of different effects. This is going to be a bit of a strange one, and I've added a bunch of content that was not in the original session. So this does have extra stuff. There was a few effects that I wanted to do that have come up over the course of conversations and such in the previous few like sessions that we've run. So for anyone that is unfamiliar at this point, despite being the last session, my name is Chris Murphy. I handle evangelism inside of Australia, New Zealand, and Southeast Asia. Alongside myself, we have two others that are on the line right now. We have Tony Reed and we have Alex Stevens. Tony handles the Australia, New Zealand territory, while Alex handles evangelism like myself, except he's more of an engineering background, and I'm more of a technical art background. So I'm gonna switch over now, and I'm gonna begin working on an effect that is gonna be post-processing. So give me one moment, and I'll switch the computer over. All right, my apologies for that, folks. I had a couple of hiccups going on at the end there, but everything is sorted now. So, sorry about that. For some reason, I'm running into a couple of tech issues on this setup, but let's go. So what I would love to do today is I'm going to begin by looking at something that a few people have asked throughout the course of the sessions, and that is the conversation keeps coming up about how would you handle something that looks more stylized. So how would you handle something that looks a bit different to your standard fare, and what could you do to kind of make something look visually different? So what I wanted to do was actually give folks an idea of what post-processing looks like. Now, to do post-processing, I mean, we've already stepped through the basics. Like in the interior environment demo and in the exterior environments, we touched various post-processes. But what I would like to do today is actually look at getting those post-processes and modifying them through their materials. So what I mean by that is we're going to change how everything looks inside of the scene by getting the image and pretending that the stuff that we see on screen is actually like a texture, and making modifications to it. So I'll show you what that looks like as a setup. I'm going to create a material, and I'm going to call this m_outlines. Now my m_outlines is going to it's going to be used for our post process, and I need to change a few things up. The first of those is I need to set the material domain as the post process. Okay. Now the cool part here is that when we do that, you can actually do we can actually start to add nodes. So at this point, I'm just going to drag in an example for this, and I'm going to add this as post-process input 0. And purely so that we can see what's going on, I'm going to turn off red in my final, sorry, I'm going to turn off red in my final output, just so you can see that something happens when I've enabled this. And I'll explain what I have here in just a moment, but for the time being, so it's going to do something weird like that, okay? Now, if I was to go to my post-processing volume that's been set up, and I was to look for an area called blendables. So if we scroll down here, we actually have this ability to go to post-process materials. And at any point, you can override the settings that you have here in your post-process materials, and you can set new settings. So in this case, what I want to do is I want to add a new post-process material, and I'm going to tell it to be an asset reference. Now, for the asset reference, I'm going to set this up to be outlines. And you can see the second that I did that, we got the scene as we had been seeing it, except this time we have that strange blue overlay. Okay, so here's where I wanted to step into the first of the subjects that we weren't historically covering in this session, but how to make something have outlines on it. So if we wanted to do something that was a little bit crazy, what we could do is we can actually leverage some of these setups, and we're outputting to an emissive color. So how this works is this here, this post-process input 0 scene texture, what it represents is how your screen would look without any additional changes. Okay, so this is what your screen would normally look coming out of Unreal Engine. But what we can do is we can do anything extra beyond the point, like through this. So an example of that is if we wanted to, we could sample the scene depth. Okay, so we could sample the scene depth at any point. Now, if I get the scene depth and I divide it by 1,000 and plug this in, let's take a look at what we see. So we can see we have kind of this weird ghostly environment going on right now. But what I'm actually doing here is I'm saying to this, all right, how far away is every pixel that we can see? And by dividing it by 1,000, it means that anything that is 1,000 units away, or 10 meters, is going to be a value of 1. Whereas anything that is up close to my camera, like if it was touching my eyeball, it would be a value of 0. Okay? So we're just kind of outputting the depth of the scene. Now here's a really cool thing about having the information about the depth of the scene. If you were to look at the depth of the scene and compare it to the depth next to the current pixel, what you actually get is you can look at the difference between them all. And what I mean by that is you can tell if something is in front of something else by saying to it, hey, how big is the gap between you and the pixels next to you? So there's this great little super simple algorithm that you can do, which is getting the scene depth. And what I'm actually going to do is I'm going to add, line them up. I'm going to add all of these scene depths that we can see here together, but I'm going to make each one represent a pixel up, a pixel down, a pixel left, and 1 pixel right. So this will be like vanilla regular scene depth, whereas these ones will be the offset pixels. Okay, and to do this is reasonably simple. We actually have a great node for just getting those things called blur samples, and this actually just gives you the coordinates for right, left, down, and up. So I can do this really quickly by just plugging this in. Okay, so by getting this information, now we want to add, we want to see what the difference is between all of these and this. And if the difference is substantial, we're going to turn that into the outlines that we see. So if I want to get this minus this, and this minus this, and this minus this, and this minus this, the quickest way for me to do that is to actually get this, multiply it by -4, because that way it's this times -4. And then just add all of the existing ones together. By the way that I'm doing this today is a very quick way to go about it. So there are better outputs that you could potentially be getting. Okay, so I'm going to get these, and I'm going to tell them I don't want to get any values above 1. And you can see that that's what we see now. And when I apply that to the scene, this is what we see. So we've just kind of created this really cool little simple outline shader, okay? By getting the depth and just saying, hey, what's the difference between all of you? If any of them have a depth that's greater than 1 centimeter, we're going to see this difference, okay? Now, it is worth noting that if you want to, you can actually apply materials like this so that they happen before the tone mapper. So what I mean by that is if we were to get this, by default, they happen after the tone mapper, but we cannot tell them to happen before the tone mapper. So before we run our anti-aliasing and stuff like that, we could do this effect. And I want you to look at what the difference is. This might be pretty hard to see on stream, so I'll do my best. But I want you to look at the difference in quality between what you see there and when I flick this over to being before tone mapping. Okay, so I'm going to hit apply. It may be a little tricky to see in the stream, but what you should be seeing here is we have like much softer general outlines. Is that coming through all right there, Alex?
Yep.
Great. So as I said, we can kind of have a slightly different effect here. And now the cool part of all of this is, you know, if we wanted to do outlines in some capacity, we could do some pretty interesting stuff. Because not only do we have like this to obviously quickly get some outlines, but you know, we could go ahead and get the original scene texture that I had, which is this. And I'm just going to set this again to be post-process input 0. Now, if we were to flip this so that white represented the outlines, sorry, white represented the non-outlines and black represented the outlines, what I could do is this. Let's have a quick look at what that would look like. So we now have a white screen with black outlines, okay? Now, if we have a white screen with black outlines, what we can go ahead and do is multiply that against the original image, where anything that is now black here will stay black, because 0 times any number is still going to be 0. So it may be a little tricky to see. You can see some of the outlines happening on there. In hindsight, this was not the best example to be doing it on, but that's okay. So you can kind of see if I'm looking through this translucency here, get a little bit of that. And if I was to turn up the light, and I can also increase the, it might be a little bit tricky to see on the stream. So what I'm actually going to do is I'm going to go back here, and where we get the outlines, we're getting this offset amount. So what I could actually do with the offset amount is I could read in a new value to this quite easily. You know, I could outline size. So if we were to get this and then set it to 4, we're going to end up with incredibly fat outlines. There you go. So see how we're getting that way more comic-y look on this character here? Like he looks more like a Borderlands style effect going on here. But again, you know, you can run some really, really interesting changes to stuff. You know, you can run some really, really interesting effects to these things. And obviously this is me just really quickly touching the, you know, the surface of it. But I want folks to be aware that you can do things like outline shaders. You can do some really cool painterly style effects. My favorite is kind of taking a Kuwahara approach. And you know, when you do something like that, what you end up with is, you know, you can get something that no one's going to look at and think that it's unreal. You know, like we could be getting the color that we see here and distorting it a bit. We could just be adding random noise every couple of seconds to get something that feels a bit more you know, a bit more interesting. So I wanted to flag this down as the first of my, first of the effects. Now this wasn't in the first session, but hopefully this gives folks a better understanding of the kind of stuff you could potentially be doing. And again, like, let's not forget as well that, so originally I have this depth mask, right? And I'm applying it, and we can see that it's applying to the background as well, but nothing would stop me from getting the depth and say dividing this by, if we wanted the effect to only happen for the first, I don't know, let's apply it for the first 5,000 units or so. If we were to divide this by 5,000, what I could actually do is I could use this at the end as well to turn off the outlines that we have. So I could actually get this depth and this outline that we've got going on, but I could say to it, actually, I want to get the white section of this and tell that to just be normal, and I want the darker section of this down here to be the outline effect that we've created. You know, so I could actually turn off the outlines for a specific region. So if we look at what that looks like, let's click apply. So he still has the effect, but as we're moving back, his effect would be minimized until it was no longer visible. Okay, so you know, we can kind of touch some strange things like that and get some interesting effects going. And I just wanted folks to be aware again that you know, stuff like that is totally doable. And you know, I could be changing the outline size by looking at the, you know, average depths within a certain region. So you know, or you could do multiple passes. You could do one pass that has thick outlines and one pass that has thin outlines based on depth. But again, I wanted to touch on this for the first of the tech art sessions as an addition to just show you something that was a little bit outside the box. Now, speaking of outside the box, I'm going to... Actually, no, if anything, I'm now about to do something inside the box. This joke doesn't make sense until you see what I do, so apologies. But let's go ahead and get this depth set up, okay? I'm going to get this part of the depth, and I want to show you another really cool effect. And that is, I'm going to create a material, and I'm going to call this box outlines. Okay, Now, this is going to be a little bit different because a cool thing is in the same way that we run translucency on, sorry, not translucency, in the same way that we run effects on post-processors, you could do the same thing with translucency. So I'm going to set this up as a translucent box, sorry, translucent sphere, I guess, in this case. And I'm going to do the exact same thing that we just had, okay? So I'm just getting this first part with the outlines. I'm going to hit apply. Again, I just want to remind folks that you're welcome to ask questions that we have in the chat. You're more than welcome to bring them up. So if there is anything you're curious about, please go for it, and Alex will jump on that. All right, so I've brought this box. Okay. Now this box is going to have the box outlines material put on it. Now the cool thing with what I've just done here is that whenever I look through the box, we can see that outline pass that I just did, because it's kind of running all of those instructions on top of it. Now, awkwardly, because it's technically the surface of the box, watch what happens if I move inside of it. So it's only the surface of the box that's going to be doing that for us, okay? But, you know, that's actually still kind of cool, because one thing that I would personally love to do is if we go about this, we can actually disable the depth test on this material, which means this thing isn't going to know where it is. And the other thing we can do is we can set it up to be two-sided. Now, watch what happens when we make this have a disabled depth test with two-sided. Random question, is there a way to have a visual representation of where the depth of field is placed? Yeah, for sure. You just go show, visualize, there's a visualize thing for it. It is focus. Is it right under my mouse and I can't see it? I thought it was there. Visualize. There is. There's actually an entire... Alex, do you mind loading up the depth of field layers? There it is right there. Except now we're looking through things. And now I've lost it myself, despite pointing it out a moment ago. Yeah. You can get the focal effect, but you'll need to be looking through a cine camera when you've got it set up. Anyway, back on what I was saying, by setting those two checkboxes, watch what happens when I go inside the box this time. When I'm inside the box, I can see it like that. When I'm outside the box, we're getting this. Okay. Now, the coolest part of like doing an effect like this is, you know, if we wanted to, the other thing we could do is tell this to only apply itself to anything that we can see that is inside the box. Because right now it does it to the whole world. So you can see when we go into it, we get this kind of cool, like almost portal looking effect. But if we wanted to, we could actually tell this to be inside of the whole box. Now, how we can go about doing that is back inside of this thing, we can go ahead and we can say to it, what is your, so I'm just going to straighten this out. Where is the world position behind the translucency that we can see? So tell me, when we look through the box, what is that position in the world? Okay. And if we were to get the world position behind the translucency, we can do what's called a box mask, which basically says make a box based on this and this position with these bounds and apply it. Now, we can do this pretty quickly, but the safest way to do it is to actually transform this into local space so that we're just kind of handling this in super simple math. Because then all I have to do is say, if we pretend that this box is in local space, we can then assume that the box is located at 0, 0, and the bounds can just be the local bounds. The size of them. And I'm going to plug this into opacity. Give it a second. And there we have it. We can now see that we have a box that I can easily change the size of. And it's going to do its thing. And kind of run this as almost like a cool looking scan effect, I guess. And you know, I mean, I could contribute away, so I could bring the color back into it and things like that too. But I kind of wanted to do something that you probably weren't going to find in your average YouTube tutorial, that was showing you some kind of like crazy kinds of effects that you could set up here that were just part of that translucency pass. So hopefully this one was of general interest to people. So the next thing I'm going to do is I'm going to quickly open up my yeah, I'm going to do the next effect inside of a different project, I think. The question was, could you invert everything in the box pretty easily? Yeah, I mean, like, to do it, you could just... I think this will work. So if I flip the mask... Give it a second. You can now see that when I'm looking out of the box, it's doing it, but inside my box, everything is fine. There's a couple of changes that I'd probably make if I was doing that normally, but yeah, that should still work. Okay. Great. So that was it for just like really quick, kind of a strange effect, but it wasn't in the initial session, but I have had a few people asking about stylization and running post processes from within Unreal. And I thought that would be a good approach to it. So I'm going to quickly switch over projects now, back to the original one that we had, and I'm gonna work through that. Okay, so give me just one moment to switch things over. Sorry, I think I must have something running in background because my machine's taking just a little bit longer than it has been for the last couple of days. So I'm not sure what's going on, but I'll be one moment. Okay, wonderful. Okay, so we've now got everything back, and we're going to be building a couple of different things in this environment. I'm going to be stepping through a few different effects, and some of these are going to be time-saving effects. Some of these are going to be visual effects. So it's a bit of a mixed bag, but I think there's definitely value in each of these things that we go through. Now, the first of these things that I want to go into is the concept of cliffs, right? So if we were to look at an environment like this, there's a good chance that we never, ever, ever want our environment to, go perfectly horizontal. So what I mean by that is if I was to sculpt this out, and I'm just going to bring this up, and then I was to get a flatten brush, and I was to just kind of flatten this entire area out. Okay. We probably never want the grass to be this kind of weird vertical like growth. It's not particularly great, right? So how do we go about overriding something like that is the question, you know? How do we set up some logic that we can always have a cliff in place? So what I'm going to do here is I'm going to bring in a texture from Bridge that we can use as our cliff texture. Okay, so once again, I'm just going to load up Bridge. And for anyone that's unfamiliar with this, Bridge is Bridge is is a program by Quixel, which is a company Epic acquired a little while ago. Bridge is desperate for me to update. There we go. Bridge is a really, really, really powerful tool. It has just thousands and thousands of free assets. Specifically, I guess 13,275 assets. And what it actually lets you do is just look through both 3D assets and surfaces and say, I want that, and just put that in your project, okay? So I've already grabbed a cliff material at some point, which hopefully is at the top of my list. Surfaces. So we've just got this, we've got this rock texture that was just on screen a second ago. There we go, rock. So I'm going to go ahead and I'm going to bring this rock cliff into my project, okay? The current settings are going to be fine, so I'm just going to export it and push it across. I'll give this just a second to handle its import. So you can see here that it's imported these textures. Okay. Now what I'm going to do is I'm going to set this up as a layer inside of our landscape, okay? I'm going to set up a cliff layer, but I'm going to do it a little bit differently to how we've done it in the past. What I mean by that is I'm going to open up this simple landscape material that we have. And unlike the other layers, so historically what I've been doing is I've been using this layer blend concept, okay? And historically, whenever I've done this layer blend, what I've been doing is I've been saying to it that that I wanted to, you know, paint in dirt or paint in grass. But this time around, what I'm going to say to it is that I want to have a cliff whenever it's vertical, okay? So a great thing with doing that is that if I go back to my cliff textures, I'm just going to drag these in. Okay, I'm just going to drag them in, and I'm going to do what I've done in my other sessions. So my apologies if it seems like I'm skipping any steps at this point, but covered this little bit in my other sessions. So I'm just going to gloss over it a little bit, which is I'm going to call set material attributes. And I'm just going to create something with base, roughness, and normal. Fix up that. Okay, so I've just created a super simple cliff material here. And what I want to do is I want to find some way that I can tell this cliff to appear automatically whenever this surface is facing upwards. Okay, so how would we go about doing that? Well, the cool thing is that every single asset in the world has what we call a normal. And a normal tells us which direction the surface is pointing, okay? And the cool thing is when we ask it for this, it actually gives us this information of whether it's down the x-axis, y-axis, or z-axis as red, green, and blue information. And by giving it to us as red, green, and blue information, I know that B, Z is B, because X is R, Y is G, Z is B. That tells me that what I can do is I can look at just the Z axis. So I'm going to mask it out and just look at the, just look at the B channel. And you can see here, this is now pure white when it's up top. It's a value of 0 when it's down here, and you can't see it, but I can guarantee you that a value down there is -1. Okay? And the great thing with doing something like this is that what we're able to do is we can say to it, you know, I would really love values that were, I'm going to give this a little bit of a buffer. So I'm going to multiply it by just say 1.1. I'm going to call this bias. And I'm then going to increase the contrast. I'm going to call this contrast. Really should have called it cliff bias and cliff contrast, but that's okay. And if we look at this over here, when I do that, this is what we're going to see. Oh, what did I change? Sorry, bias was meant to be 1.1. I thought I entered that. So, how this works is if you imagine a value and you were to if you think of 0.5 times 0.5, that equals 0.25, okay? Now, if you times 1, that still equals 1. And what I'm getting at here is that when a value is below 1 and you multiply it against itself, it approaches 0, okay? Because like it's going to do that fraction against itself again and again. So by timesing it by itself, by telling we want to do something using a power expression, what we can do is we can increase that contrast. So if you see here, I times this by, say, I do it to the power of 4. Notice that that black area kind of crept up. Do it to the power of 10, for instance. And that will, again, just kind of keep creeping up. And this bias is helping me keep a few extra numbers above 1. Like if I was to change this to 1.05, you can see that we've raised that top even further. Now, the point of all this is I can go ahead and I can say to it, look, whenever you are a white value, I want you to be the current material. And whenever you are a black value, I want you to be a cliff. Now, just before I click apply, I'm also going to turn the grass off for just a bit, just so that we don't have any of those 3D meshes just getting in the way. Now, unfortunately, building landscape materials is always going to be the most expensive thing to build because you're going to have to build all of the permutations. Under the hood, Unreal automatically goes and builds versions of them with grass, versions of them without grass, etc., etc. Oh, I forgot to saturate my value. Amusing. So this is working. I just forgot to do a... So what I forgot to do here was when I did my blend, I forgot to say don't let any values go above 1. And because I'm multiplying this value here by more than 1, it's getting a little excessive. So what that's actually doing is meaning this is normally meant to be green, but now it's super green and ending up as that strange value. So I'm just going to fix that with the saturate. My apologies, folks. Again, if we have any questions, you're more than welcome to bring them up inside of the chat. All right, that's working. So I know this was an excessive cliff. We'll handle that part in just a second, and it's got some stretching going on, but that's okay because conceptually we can see what it's done, right? Like if I'm in my landscape mode, I'm able to go to any aspect of this and I can say sculpt, and if I was to flatten this area, for instance, if I was to flatten it, the second it gets flat enough now, that grass is going to start coming out of it. Because anything that is vertical is now that, and anything that is horizontal is grass. Okay, so now I know this was a strange one, but fortunately, we have a couple of things that can really help us out here. Okay. Now, remember before I made these parameters? The great thing about those being parameters is I can come into here and I can try and find a value that actually works. So I could dial this back a bit, this blend amount that we have. And this bias, I could try... Oh, bad idea. Yeah, I could try and find points where this could work a bit better. I'm actually thinking 1.2 could work. And then I get back to my contrast and... Now, this is an ugly version of this, but it was more about kind of teaching you the concepts of you being able to just do materials that were a little bit more intelligent in terms of what they were doing. and the fact that it can save you a lot of time. Because now I'm able to go through here and have an artist kind of painting things. Now, the next thing that I wanted to bring up is some of you, especially if you're coming from like an animation background, you may be used to the concept of triplanar mapping, okay? So if you're used to triplanar mapping, what that is if you start triplanar mapping, great. If you're not used to it, let me explain it. Imagine we got a projector and we just shone the texture at it. And regardless of the UVs of that particular object, it was just projected onto it. And we did that from every direction. So what I mean by that is, we projected it from this direction, and we projected it from this direction, and we projected it from this direction to give us kind of a setup that would allow us to more accurately kind of blend things together. So this is useful when an object doesn't have UVs, or when an object, like in this case, kind of has very stretched UVs, because this rock is being stretched down here. Okay? So a couple of ways to go about fixing that is, we could scale this up, but it probably wouldn't look how we wanted it to. The other simple option is literally just bringing this in and adding a world-aligned texture node. So I can get a world-aligned texture, and this can actually be a projection. So first off, we now want this value, not this one, but also this won't connect. And the reason this won't connect is this is looking for a reference to a texture. It's not looking for the color outputs, which this pin gives you. Like this gives you the color at the current pixel, but you can tell it by converting it to a texture object, tell it to give you a reference to the texture instead. And I'm just going to do that for all of these, okay? Again, convert. Now, if you're doing something that is a normal, you probably want to use the world-aligned normal, which is basically the same. The main difference for it is it does a couple of extra instructions that are for normal maps. And I'm just going to have a value here that is called cliff size. Let's default that to a nice round number of 2048. For anyone wondering why 2048 is a nice round number, it's a nerd joke. Wow, okay, one moment. Sorry about that, folks. Like I said, OBS has been having a little bit of trouble, I've noticed, with running Unreal. It's okay. Still selected. Okay, I'll be 2 minutes. I'm just going to really quickly have to rebuild things. Again, I know it's awkward because you're seeing this on stream, but it is actually usually a lot more stable when you're not streaming. For some reason, streaming seems to be causing some trouble, specifically through this program. Oh great, it didn't actually save the import of the cliff. I'll be 1 extra minute. If anyone has any questions, now's probably the time to ask them. No program wants to update like Quixel does. Okay, sorry about this, folks. Give me the cliff. once you have content packaged on your hard drive, you can access them from other projects. So content exists in each individual project distinctly. A lot of folks that are used to film backgrounds are used to that content kind of existing like on a network drive and things like that. But in this situation, it's going to exist on a per project basis. Once you've downloaded it though, we keep a save of it in like a local cache, and it'll just copy straight in from there. So I'm just going to quickly set this up again with what you saw. Yes, you can copy things from one project to another. If you want to copy them from one to another, you can use a thing called migrate, which will copy all references that they need as well. You're just going to right click on them and go to migrate. Okay, got those plugged in. Sorry about that, folks. Okay. Got the cliff to be there, but specifically we want to have a cliff that is cliff size. Save this before I plug anything in. Because fool me once. And let's set this to 2048. Now I need to do vertex normal. I get that. I want to bias it. Does anyone remember what the number was? I think it was around 1.3, 1.4. Turned off the grass for the time being. Whew, all right, back to where we were. Save. Okay, so this time around we can see these cliffs are actually scaled up correctly.
Your screen isn't showing.
All right, sorry about that. Did I have that on Unreal logo while I rebuilt the whole thing? Wow, okay. That was a good trick. Sorry about that. We had 4 minutes of black while I quickly fixed things up and gave you an overlay. Okay, cool. This is set up exactly the same as what I had up before, or what I'm pretty sure is up before. And once again, you know, we can kind of dial in a lot of these values by looking at this cliff and saying, hey, let's try and find something that works, etc., etc. And as per usual, you know, at any point we can go ahead and we can now just kind of paint cliffs straight in, which can hopefully act a little bit more intelligently than your standard ones, because I'm able to grab this, pull this out, grab this, pull it out. And that's, you know, starting to work. That's starting to, but kind of hopefully save me a lot of time. So I just did noise and I actually wanted erosion. There we go. So that's hopefully going to save me a lot of time, because if I don't have to paint this stuff in, you know, everyone really wins there. I can spend that time on something that's way more important. And we can see that that's kind of working, you know. So the next thing that I wanted to do now that we've got that going on, is I would like to actually sort out the grass as well. So I turned the grass itself off, but you know, if you wanted to do something, I could just wholesale copy this, like code that we have here, and all I need to do is this sample that I'm using to paint landscape grass into the world, what it does is it says to it, you know, whenever there is grass, it's a value of 1. So if you think about it, all we need to actually do is multiply this grass against this in some capacity. And I'm going to change this to be called like grass cliff bias and grass cliff contrast. Just so it's saved as a different value that we can independently tweak. But if I was to get this, and I might also just, I might also round it up. So it's kind of an on-off situation. It's not increasing density. Oh, sorry, not seal. I want to use a round function. So I can see now there's a hard line from this point onwards. So if I was to get something like this, you know, we can now tweak it as necessary. Which it could be any number of values here. Let's do a really high one first off to see how it looks. And I should definitely plug that in. Okay, so give this just a second. And this should now fix up our grass placement as well. Now the thing is, I want you to keep in mind that I'm doing it for this, right? But nothing would stop you from doing this as an elevation blend as well. So maybe beyond a certain elevation, it automatically paints in snow. There we go, we can see it happening there. So in this case, those values were actually surprisingly good for a first-time guess. The other thing you could do is you could make it that whenever there's no grass and it's about to fade into cliff, it goes through a dirt layer first, so that you know you end up with a much nicer kind of blend going on for that kind of situation. But you know, I mean, this is automatically adjusting to what I'm doing. So what I mean by this is, if I'm painting this back in, I can tell it that I want to flatten. And then it just gets rid of all that grass for me. And as always, I can kind of erode those down a bit. And kind of clean things up from there. So hopefully everyone can kind of see the value in that. You can see why that's a useful technique to employ in your projects, and why some smart assets can really go a long way in getting things up and running. Okay, so I'm gonna save this off now because we're pretty much done with it for a while. We're gonna do something at the very end, but we're good for a little while now. The next thing that I want to jump into is mesh painting. Okay, so I'm gonna save this off. Does anyone have any questions about the work done so far? Okay, so the next thing for me to do is I want to get this rock, and I want to work on painting it. I'm just going to make this a slightly bigger rock for us to deal with. This rock did not come from Quixel. This is a rock that was made for a mobile project a while ago that was cancelled. It was a game called Infinity Blade Dungeons. Okay, so we've got this set up. The next thing for me to go ahead and do is I want to be able to paint this. So let's take a look at this, okay? I'm going to find the material. This is the default rock material. And I'm going to drag this over here, and I'm just going to copy it into my root folder, and I'm going to call this m_paintable rock. Okay. Now this is a very, very, very simple material. It's by no means fancy. Okay. And what I'm going to do is I'm going to add a vertex color node, and I'm just going to plug that into my base color. Okay. Now this vertex color node is going to be the key thing that we're studying for just a little while. Okay. Because what I want to do is I want to get this paintable rock material. I'm going to put it under here, and you can see that it went white. Now the reason it went white is because if I go to mesh paint, what this actually lets me do is paint. And I can choose to paint stuff out by holding shift and left clicking, or I can choose to paint stuff in by left clicking. And the great part is so this is painting per vertice, but you can actually also specify paintable textures as well. So you can just paint straight onto any asset and paint in differences and paint in all sorts of variations. So let's take a look at one of those things. Like what if I got this and I told it that I want the red channel to represent wetness. So if the red channel was to represent wetness, I could say, okay, by default you're a value of 1, but whenever you are wet, I want you to be a darker value. So let's bring it down to like 0.2. Okay. The other thing I want to do is whenever you are wet, I want you to have a very low roughness. So let's punch in a value like 0.1. And the advantage in doing it this way is if I go back, okay, I'm going to turn off my green and blue so those values won't change. I can now paint wetness straight into this specific asset. And if we wanted to have another rock, it's going to copy that initially, but I can still comfortably go back to this next rock and say no, you are drier, but this bit's wet. But you're not. I don't know. Okay, so I can kind of add this variation, and nothing stops me from doing other stuff too. Like nothing stops me from saying, hey, the green channel represents moss, and I can paint in moss wherever I wanted to, or something of the sort. So I just wanted to flag mesh painting in as a useful little technique that a lot of folks are unaware of, because it really helps you add easy variants to your scene. And you don't need to have like 5 versions of the same rock in the scene that are different, have different materials on them. You can just build a nice generalized material and use that to kind of inform the rest of your design. Okay. Cool. So the next thing I want to do is I'm going to duplicate this, and I'm going to show you a thing called world position offset. And I'm just going to delete the wetness stuff that we just did. Can you paint vector displacement? You can paint into the tessellation, the world displacement and the tessellation multiplier, I believe. I'm pretty sure that works because it's on the vertex shader, so it should be fine. Okay. So, the next thing for me to cover is world position offset. And I want everyone to watch what happens when I plug in the number 500 into world position offset. I want you to look at the rock, okay? Watch the rock, or the circle. It's over there. Okay? Now, the reason it's over there hopefully becomes a little bit clearer. So I put a value of 500 into here. Now watch what happens if I put in a value of 00500. So the reason this is happening is world position offset lets you offset any vertice by this by this distance in those directions. So the reason it went diagonally the first time is because it went 500 along the X, Y, and Z axes. Okay? So what I want to do here is, all right, so this is kind of cool. But first off, can we do anything dynamically? Well, if we get a sine node, so a debug times sine, and this value just goes black to white, black to white, black to white, 0 to 1, 0 to 1, 0 to 1. If we were to multiply this against that 500, you're going to see this asset is now able to do that. Okay? Now, what if instead of doing 0, 0, 500, we looked up that same value that we had before? Remember earlier we had the vertex normal? Well, what if we plugged a vertex normal into this? It's getting 1 centimeter bigger and 1 centimeter smaller. So I'm going to multiply that by a bigger number so it's more pronounced. Let's try 10. I'm also going to apply the actual rock mesh in the scene. So I'm going to get this mesh and I'm going to apply it to the rock. We can now see that we have a pulsating rock, which is just what I'm sure you all expected to see when you came into this session today. That's a perfectly normal thing. So we can see here that what's actually happening is the reason it's pulsating is because it's being told to move 25 units in the direction that that surface is facing. So every surface moves outward relative to whichever direction they're in, which gives us this ultimate effect of it looking like it's pulsating, and some bits get smaller, some get not smaller, but some get squished in and some don't. Okay, which kind of creates this. Now, this is where things really start to get interesting for me, right? Because when we look at something like this, we can say, all right, it's pretty cool. Can we do this in just one area? Is that a thing that we can do? Well, let's check. What if I was to say, let's look at the world position of our object. Specifically, let's look at the height of the actor. Okay, so remember that looking at the height of it, this B channel, it's pure white up here, but it's pure black at the very bottom because 0 on the z-axis is there. Okay, but what this is telling us when we look at it like this is, if we wanted to, I want you to think about what happens if we were to get the maximum value between its height in world space and the number 0. The maximum value means that no negative numbers exist anymore. While these were like -20, -10, -5, etc., etc., they're now a value of 0. Whereas up here is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You know what I mean? Like, this is the distance that they are from this offset. Okay? Now, think about this. What if we wanted to move everything down this far? Now, if we want to move them downwards, we have to tell them, move them down. So negative on the B axis, which is Z. So it's pointing downwards. I want you to watch what happens this time around. So everything above it is squishing itself down to this point over and over and over again. And if I get rid of the debug time sign so that we're no longer like just doing things over and over again, you're going to see it here. And the reason that they're going completely and perfectly flat is because this is telling them to move downwards this many units. Okay? And if we were to look at the numbers that's coming out of here, the height value is telling me the height value is telling me that, you know, if this is 20 centimeters above the ground, above 0, 0, move it down 20 centimeters. If it's 2 meters above it, move it down 2 meters. You know, like it's actually, it's being moved down its own height, which is resulting in it being at this point. Okay? Now, by having that, the cool thing is we can get this height, and if we wanted to, we could subtract a number from it. Now, if we were to subtract, I want you to look at the white, like the white and black divide and where it's located, and watch what happens when I subtract 200 from it. Move to there. If I subtract 800 from it, the whole thing is black. Now what this tells us is we have the ability to pivot where that line is. Okay? Which means if I wanted to, I could use this debug time sign to move the line up and down the object. And if we look at the result of that, we get this. Now the cool part of having something like this is we can then go off and use data like that. And keep in mind this debug time sign, like this value that I'm using here, I'm just using that as a way of showing it on and off, but this could be a parameter value that you can control in sequencer. You know, nothing stops you in sequencer from grabbing this debug time sign and saying to it that that, you know, you want it to be set explicitly to 0.4 or explicitly to a value of 1 or explicitly, you know what I mean? Or you could modify it over time yourself. So, you know, this is a perfectly animatable thing down here. I just like to use this because it'll keep showing me kind of playing back and forth, and I find that pretty useful. Cool. So, the next thing for me to do is start actually playing with some of the extra like logic that we have here, because if we think about this section here, like this value just here, an interesting thing happens if we were to divide that by 20, say. Now, I'm just going to preview that. Notice it got way less bright. Not only did it get less bright, but this here has a bit of a fade to it now. It's not just a hard line. And the reason for that is because this black value is 0, and then it goes into negatives, right? But that means that the value between 0 and 20 centimeters is now a value between 0 and 1, because 20 divided by 20 is equal to 1. So when we hit a value of 10 centimeters up, that's going to be a value of 0.5, because 10 divided by 20 is 0.5. Okay? Now, if we got rid of those negative numbers and we told them, hey, get every negative number and make them positive, we would end up with a black line instead. Because as it went from 0 to negative 20, it now goes from 0 to 20, which means it goes from 0 to 1 all over again. Okay? Now, the fun part of what we have there, actually I shouldn't have done that from there, I should have done it from after the subtraction, because now it'll move. The fun part of what we have here is I'm able to clamp it, which is a saturate. A saturate is a clamp of 0 to 1. So no values go above 1 or below 0. And I can, let's flip it. So that black becomes white and white becomes black. Now we have this white line moving up and down it. And because we have a white line moving up and down it, what we're able to do next is we're able to say, all right, let's multiply that by a really bright color. So let's say I set that to 20, 30, 500. And I plug that into my emissive color. Oops, sorry, I'm still previewing. you know? So, like, stepping into this kind of stuff means we can do some really kind of cool and crazy and quirky effects. And this was just me doing, like, the absolute bare bones of this effect, right? But conceptually, I mean, really, all I'm doing is I'm moving a line up and down the asset. And it's worth noting that, all right, this actually does need one other thing that needs to happen for it to really work. So this is currently doing it in exclusively world space. And what that means is if I drag my rock into the scene and I apply the material that we have, paintable offset rock. This is currently doing it in world space. So if I was to drag it up to here, we won't see it. It'll still be trying to do it all the way down there. So what I actually need to do is kind of localize that space a little bit, which means I need to get my current position and subtract the object's actual position. Side note, the stuff that we're doing in this session and in the previous session is the stuff that I like generally do for a living, which is I'm just way more comfortable doing. So we can now see that this is doing it here, right? And even if I move this asset up, it'll still spin up. And I can put it sideways, and it'll still do it. Okay, so yeah, and there's extra logic I could put in there, but I hope that just generally you can see the kinds of stuff and like, you know, where the power in an effect like that really lies. Because did I just apply this to this somehow? No. Something is compiling, and I don't know what. I think I just applied that to the grass or the ground. In 10 shaders, we're about to see what I just did. Alright, I didn't know you could override the grass material, but turns out you totally can. Okay, sorry. Okay. Did you know you could do that, Alex? Because I sure didn't. Instead of figuring out how to undo my grass change. Oh man, this session has not gone according to plan, but that's okay. So, okay, I'm gonna apply this. I'm gonna apply this one, and what I'm gonna do instead is let's have a quick look at what that looks like when applied in a different capacity. Okay, so I'm actually gonna open up old-mate content examples all over again. It is Friday. It is Friday after 2 weeks of running these sessions. So it's by the way, for what it's worth, thank you all for attending on a Friday night. I mean, I know most of us are in lockdown, so we probably don't have anywhere else to be, but I'm still flattered. Okay, so I'm going to go to here, and I'm going to open up a level called Pivot Painter 2. Because what Pivot Painter 2 is it's running that exact same logic that we saw before of using world position offset, but it's a script built into 3ds Max that actually lets you bake out information about sub-objects in your mesh. Sub-objects or actor hierarchies, okay? Now, if you have sub-objects or actor hierarchies, that's how you can start to add that little bit of wind sway to your assets. You can see that more substantially over here. And again, I can see that really substantially over here. But you can also start doing cool things like growing the tree out hierarchically. So the trunk, and then the branch, then the next layer of branches, then the ones after. Or, in a rather cool thing, this entire house is purely being built through the material. Okay. So this kind of stuff is the same technique here. And keep in mind that, you know, this project is free. So, like, you can open any of these things, and I can just look at the house building material. This is a 3ds Max script, but it is worth noting that the 3ds Max script, there is a Houdini version floating around somewhere. But you know, I can look at what's actually happening here, and I could just copy this material out for myself. Side note: it looks really weird when not actually applied to a house, because it's using a data texture for each section of the object. Okay, so like I said, you know, I just kind of want to expand people's minds on what they could be doing with their materials and shaders, and where you could use some of this stuff. Cool beans. Yeah, no. All right, cool. Next up, so we've done vertex position. We've done some vertex position stuff. What I'm going to do next is I'm going to move from here over to render targets. Okay. So render targets are a really cool concept. Now, some of you were in my session that I ran earlier today, my session on visual effects, which, for the record, for anyone that caught the previous session on VFX, the one today was like 10 times better. So, sorry. Yeah. So, anyway, let's go ahead and let's build something kind of interesting. So, we're going to be working with render targets now. Oh, no. Sorry, I actually totally skipped a thing. I was about to jump into render targets, but that's actually not what I want to teach yet. Sorry, everybody. False alarm. We're doing that in a minute. What I want to do now is interior mapping. Okay? Now, in Unreal, you have the ability to drop in what's called a scene capture actor or a scene capture cube. And these take a photo of the world. In the case of a scene capture cube, it will take a 3D image of the world and save it out as a texture, okay, like a spherical image. So the reason I bring this up is I've already actually gone ahead and done that with one of these things, okay? And I'm just going to quickly grab that file and I'm going to bring it in. Just quickly copying it in. Great. So I did this from a different project just because it had a pretty looking room that I could use. Okay, so I've brought in this cube RT. So this is all it is. It's literally just this image. It's a 360 image. So if you see there, you can see that side of the shelf is this shelf just here. Okay, nothing fancy. Now, the cool thing is if we get something like this and we were to get a new material, okay, then I'm going to call m_interior. You can actually get 360 textures and you can apply them. So I'm going to plug this in, and they need to know, if they're 360 textures, they need to know which direction you're looking in. And the most obvious thing that you could do is you could get the reflection vector, which allows me to kind of peer into it. Or I could get, alternatively, the camera vector. So we can now see we've got this going on. Okay. Now, if we've got the reflection vector, the other way to do this one is to multiply this by -1, which gives you the camera vector. Okay. So I bring this up because, all right, so we can kind of get this weird thing where we're kind of looking through the object. Okay. But really what I wanted to show you, and this is an important aspect, is we can work with some other really cool concepts here. Okay. So for a second here, what if instead of doing anything like this, we actually used a thing called an interior cube map? Okay. If we get the interior cube map function and we plug this into the UVs, look at this. Look at these tiny little rooms spread out inside of my box. And I'm going to just drop this tiling down to just 1. Okay. So I can see here that that's going in there. Actually, I'm going to keep the tiling up for a second because the other thing that we can do is see how this is the same room, the same angle every time. If you want, you can actually say randomization, turn this on, and now it will pick a random direction from the cube around the z-axis. So it kind of looks like different rooms. You know, if you hadn't made these very silly decision of having a window in one of your areas, which in hindsight was a terrible choice. But we can see here now it's like we're peeking into little mini rooms, right? And if I was to save this and drop this onto a cube, Actually, I'm going to import a different cube. I'm going to import this one. The only difference between this cube and a regular cube is it's just got a pivot point in the very bottom center, which is easier for what I'm about to demonstrate. So I'm going to drop this cube into here, and I'm going to imply my interior texture. Okay? And we can now see that it's like we're peering into a bunch of rooms. And, I'm going to make this a lot bigger. And as I am, we're able to kind of just like look through, and these rooms don't exist. They're literally just a photo of it. And you could actually go one step further if you really wanted to, and you could actually do a depth pass so that these objects still had some semblance of 3D once you're inside of them, which is another cool technique. But in the meantime, we can see here that we've got something, all right? But here's the problem, right? If I make this bigger, my rooms get bigger. And if I make it smaller, my rooms get smaller. But you know what I would really love? What I would really love is to add rooms as I made this bigger. You know what I mean? So like as I enlarge this cube, what if the material could look at how big it was at a specific area, and I could say to it, all right, cool, I guess we just increase the size at that location. Okay. Now the key to doing a technique like that is all in the UVs. So all of this part beyond here. Okay. So what we need to do first off is we need to say to it, well, which direction are we looking? And this is where we go back to that vertex normal that I mentioned earlier. Because this will actually tell us which direction we're looking. Because if it's green, it's the y-axis, and red is the x, and blue is the z. So that's the first thing that we can do. However, we need to get this vertex normal relative to its local direction. Because if you think about it, we don't need to know if it's the x-axis. We don't need to know if it's the x-axis in the world. We need to know if it's the object's normal x-axis. Like I'll show you what I mean. So I've just applied this to the cube. Okay? And we can see here that we have green, red, and blue. Yep. However, I'm going to clone this. However, if I was to rotate this, we now have purple. And the reason this is purple is because this is both facing that way and facing this way. But we still only want to know how big this wall was. We don't actually want to know the direction in the world it's facing. We want to know the local direction. And the way to do that is to get that normal and say, hey, transform this direction and convert it from world space to local space. And this will now tell me which direction it is relative to forward of the object, not forward to the world. Okay? And we can see that if I plug it back in. Because if I go to here, we can see that it's red, blue, and green still. Now, it's a good idea, as I discovered in the previous session, to normalize this. Normalizing this just makes sure that these values are correct and they all add up to 1 wherever they should. Okay? Which we discovered in the previous lesson needed to be done sometimes. Okay? So I've plugged that in. We've got that reasonably well set up. And this is actually the almost completely done. The next thing I need to do is see we have these black sections. These are black because this is red. This is negative red. This is green. This is negative green. So what I actually need to do to them is I need to abs them. Absing, again, same as we did before. Like you'll notice this is the same math and the same logic that I'm kind of smashing out again and again. But absing something makes the negatives positive. You can think of it as the most optimistic node. All right, so we're kind of mathematically just getting rid of all negatives and converting them to positives, which is giving us this like blue section, this green section, and this red section, right? Now, by having those kind of all set up, what I'm going to do is quite simply use these as a way of scaling my material. Because I can actually look up the object I thought it was called object size. Object scale, sorry, object scale. Okay, so I've got this node. And this gives me the scale of the x-axis, the y-axis, and the z-axis. So what I'm going to say to it is, well, let's get your x, y, and z axes, and let's say to it, look, whenever it is your x-axis that we're looking at, I want you, well, if we're looking at your x-axis, we're going to be looking this way. So I want you to multiply your z by your y. So y is, I want to append, oops, not append many, append. I don't know why append doesn't pop up under append. You have to type in append vector. Now I know why. Cool. So we want this to be y right, z up. And then we want to ask it, all right, so if it's not that, and it's the y-axis, then we want to append, well, let's look at it. Okay, if it's going to be the y-axis, the green, I can see that it's x to the left and z up. So it's x left, z up. And finally, if it's neither of those, then logically it has to be xy. Okay. Now this should now give me the scale in any direction that it's facing, and we can check this because we can multiply this against our UVs. I'm gonna ditch this tiling here. Actually, let's get this tiling to be a value of 1. Okay. Cool. Get rid of you. It's not plugged in, is it? It's totally not plugged in. GG. All right. My dramatic reveal was just ruined. Off the team. Cool. See that? Watch this. It's literally just adding extra rooms in to compensate. Because if this is a size of 2, it's multiplying the UVs on that axis by 2. Now, one of the cool aspects of this that I really love is if we get the this scale, okay, if we get this scale and we round it upwards, or we seal it, that works too. Sealing it rounds it upwards always. So if it's 1.1, it's now 2. You can check this out. See that? Actually, see how the rooms are popping in? Alternatively, instead of sealing, we could round. And if we round it instead of sealing, it'll stretch it either bigger or smaller to fit the nearest room. So see this? So see how it's kind of just popping in those extra rooms now to compensate? Okay. And the advantage of this is, if you're building a room, you're building some stuff. I mean, like hopefully this is pretty obvious as to why that's useful. Because I don't have to model that environment. Because the truth is like for what we're looking at here, the next step beyond this whole thing, so this is I'm going to put a comment around these and call it cool windows. Okay, so we've got our cool windows. By the way, you just hit C to add comments. You can also change like the font size, for these things, so it's a bit easier to read. So we've got our cool windows here. But, if we wanted to, we could easily add an exterior to this. And really kind of build on our cool windows. What I mean by that is, let's add, I don't know, one of these things. I can't remember which. Great. So, if I wanted to, I could get this concrete and I could get the facade textures. Okay. And what I could actually do to it is I could say, let's put a normal on this thing, but let's also tile the normal in the same way. Okay. And since we're tiling the normal that way, I believe it's the alpha channel of this. If we look at the alpha channel of this, it's white wherever it's Windows and it's black wherever it's not Windows, which tells me that we could run the current base color into the white channel, but we could run this concrete into the black channel, and we could do the same thing over here with this one. So apply U, and so I could say, hey, whenever it is this, I want to, whenever it's the normal windows, I want it to be upwards, and whenever it's the exterior, be that, with the alpha being this channel. And I'm just going to do this like bake normal. What is it? Blend normal? Blend angle corrected normals. That's the one I wanted. So I could get that and do that. And what that setup should give me, if we stop previewing this thing, is an exterior that's going to keep adding windows, as we scale up the building, right? And the cool thing is like I can comfortably do this, and I could have this here, but I could also have this here. And like there's nothing that stops me from meshing the stuff that's all on the bottom, and then add a bunch of rando, I don't know, stairwells and air conditioning vents across the rest of it. And like all I'm getting at is like by doing what you've got here, you're able to just skip work. I mean, honestly, I know this seems like the mantra of basically this entire session. It's just, how do we not do work? But if you have to make an entire city, I don't know about you, I'd much rather it if that as the camera came past, they saw interiors, but you didn't have to mesh every single interior, because that would be lame. There's a better use of your time. So I just wanted to flag that a technique like that was completely possible. You can look at the scale and you can determine it, and then you can just act on that with whatever information you need. Cool. Okay. So the last thing I'm going to do, we have such a weird collection of stuff here, but the last thing that we're going to do is I want to burn this place to the ground. I want to have a giant death laser that comes in and melts the world, because yeah, I mean, why not? It's Friday, right? So let's do that. So if I were to make a big old death laser, how would I go about it? So I'm going to create a blueprint, and it's going to be an actor, and I'm going to call this BP laser. I mean, I say death, but it's really only going to be killing grass. That's okay. And I'm going to add a particle system to it. And a particle system, in this case, is going to be a beam that I have already created. That's right, here's one I prepared earlier. Now, if I was to drop this into the world, some people would be comfortable with their giant death laser merely throwing artificial rocks out of the ground. And like, I don't want to use the word quitter, but we can do better. So what I want to do here is I want to first off let's cap the end of it, because just there's a part of me that dies at the notion of that just touching the ground and being fine. So let's fix that first off. So I'm going to add a static mesh, and I prepared a mesh earlier called lava blob. And if you actually want to look at this, I'll make it real big for a second so you can see it. Oh, too big. This texture is actually following the same logic as the pulsing rock that you saw before. It's just only pulsing outwards at certain times. So I want to stick one of those at the bottom of it just so we can get a bit of this lava action going on. Okay, so getting a bit closer to what we want. Now, the next thing I would like to do is I would like to destroy all of the grass in this scene. I would like to leave behind it a trail of molten lava and just have abject destruction. Okay? So, how? Well, the cool thing is if you think about it, abstractly speaking, a giant death laser is essentially a paintbrush. Okay? And what we're going to be doing with this paintbrush is we're going to be painting, and wherever it paints, we want a wave of destruction. By the way, if this ever comes up in a court case later in my life, just don't put two and two together, I request. If there's... So why did you have this giant death laser? You said it was a paintbrush. So what we're going to do is we're going to get this laser, and we're basically going to paint this landscape. Okay? Which means I need to be able to do a few things. I need to be able to paint to a texture, and I need to be able to preview a texture such that it fits across this entire map. Okay? So what that actually means I need to do here is I'm going to open up my my landscape material. Actually, no. First off, I'm going to show you something. If we look at the landscape, this is how big the landscape is. Okay? Now, by having this landscape this size, if I hold my middle mouse button down and drag across, it gives me a ruler. Probably should have told you about that earlier, but now you know. So what this ruler actually lets me do is see how big the landscape is. Now, because I'm a nerd, I know that the default size of a landscape is 50,400. Okay? Now, that means that this corner is at 0, 0, and this corner is at 50,400, 50,400. Why do I bring this up? Well, if I was to look at the world location of any pixel that was on the landscape and divide it by 50,400, it would now be a value between 0 and 1, much like a texture. So if we were to go back to our landscape material, which is somewhere in here. So if we were to go back to our landscape material here, and I was to just for the time being, I'm going to just going to ignore everything else after all of our hard work, I know. And I'm going to get an arbitrary texture with no product placement whatsoever. And I'm going to look at my world position. I'm going to get just the X and Y coordinate for my world position by doing a component mask. And dividing that by 50,400. Okay, so that set up. Okay. Give it a second. Almost. Uh, 50,400 is just the default size because that's the section size by the quads. Just happens to be that number. But I mean, you can measure it yourself, or you know, when you're creating a new one, you can if you go to new, you can set up different sizes. It's just this happens to be the default value. All right, so I can see now that I can get a texture to be projected across the entire landscape. Okay, and now what I'm going to do is I'm going to create what's called a render target. RT brush is what we're going to call it. No, RT destruction. Okay, RT destruction. And I'm going to set this up to be 1024 by 1024. Now, a render target is a texture that can be dynamically painted onto by a computer. Okay? So in this case, I'm going to go back to my simple landscape and I'm going to plug in my RT destruction. I'm just going to hit apply. Now, it's going to be black for the time being because now I have to think about my next steps. Okay? And my next steps involve saving everything because I just don't trust this computer anymore. But my next steps involve creating a brush. Okay? Because what you need to do is you can render any other material onto this texture. Okay? So to do that, I'm going to create a material that is going to be called brush. And now this next bit that I'm doing here is going to be a little bit of like just general math. But essentially, if you know the force location of something, and this is between 0 and 1, you can look at the distance to where it is on a UV channel, which will give you, see that black to white radial value? It's because my location was 0, 0. But if my location was 0.5, 0.5, which would be in the middle of the UVs, we're now going to have a dot here. Now, if I was to do a 1- on that, and then I was to just kind of create a value for force size, and do set that to like 0.5, I guess. And I also do a 1- on that, and then subtract A from B. Again, like this is just some math. This material is totally available for you to get for free from one of the learn samples. So I actually don't really want to, like it doesn't matter to me if you don't quite get this material. What matters to me is you understand the purpose of this material, because then you can go follow that off on your own. And I'm just going to divide this by this. Okay. And then finally, I'm going to multiply this by some sort of value that's like force power, because we're definitely not Star Wars. Okay. The TLDR of what I just did is we're now able to change this force size to be like, hey, you're this big. And it'll do a little dot. I can be like, hey, you're all the way big. And it'll fill everything. 0.5, just here. Okay? And I could move it around by saying, hey, you're all the way to the right. Gradually reenact the opening of a James Bond film. Force location. Okay, so the next thing for me to do, I'm going to align these because it hurts me. Q. All right, so the next thing for me to do here is I'm going to set the unlit, because we don't care about any lighting information. And essentially what we're going to be doing is getting a blueprint that is able to set these values. Okay, so in my laser, I'm going to go to my event graph, and what we're going to do is we're going to say to it, all right, the second the game begins, I want you to create a dynamic material instance. This means create a material based on an existing one, but let me change some of its properties. So basically this is why we save. One moment, folks. If anyone has any questions, you're more than welcome to ask them now. Okay, cool. We're back up and running with exactly where we were. All right. So when the game begins, I want to say, give me a create a dynamic material instance, which means create a version of a material that is something that I can modify. Yeah, it's kind of killing me. It seems to be to do with OBS, but I haven't quite pinpointed which part of OBS is causing the crash. Anyway, so this is going to create a dynamic version of that brush, which I'm going to call brush. Okay, easy. And then all we're going to do is we're going to tell the game, hey, every time you tick, I want you to get the brush, and I want you to set a vector value with some information. And the first thing I need to set is we had a value that was called force location, which is going to be my actor location divided by 50,400. Okay, and then the next thing I needed to have was again my brush, and I'd be like, yo, how about you set a scalar value this time? And force size, but this is going to be the same thing, right? It's going to be a it's going to be the size of the brush, which I'm just going to say 1024 divided by 50,400, because they have to be between 0 and 1. And then the last thing I needed to do was the multiply, which is how many of these per second, and I'm going to say going to do the time it's been since the last time we ticked multiplied by like 10. Cool. So that's setting all the values, and if we're setting the values, the last thing that we logically need to do is draw the material to a render target. Deleted my render target. Or it didn't, and I just can't spell. More logical. So the material that we want to render is the brush. Anyway, here's what happens. I'm going to go back to here, and I'm going to hit play. Alright. I messed something up, but that's okay. It's mostly working. And if I was to move my laser around, it's doing this. Okay, kind of looks like it's having a rave. Let's figure out why. That's why. I wrote force size for both of these instead of, I think the last one was like force strength or force multiply or something. Let's check. Force power. Okay. Where is it? Laser. Force power. Unless you have power. It's kind of funny if you think about it. If there's the one thing that I should have had, it was the power. For anyone that doesn't get that joke, that's an intro reel joke. All right, so we've got force power plugged in, and if I was to play, this time it's working because I'm not acting like an amateur. All right, so if I was to draw this, we can now see we have a white circle anywhere on this texture corresponding with where this is. Now, a really cool thing that happens is if you open your brush and you set it to be additive, it actually keeps all the information that's already there whenever it draws. The reason that's useful is that when I draw, pull back, when I draw, it's now going to create a trail behind it. Okay. I know it's a very grassy trail. For the time being, I'm just going to turn the grass off just because it's ruining my whole shtick. Very cool. Now, the other thing I want to do is when the game begins, I keep saying game, but when the scene begins, I actually want to clear the render target, just so it doesn't keep the destruction from the previous time I played. Play, laser, move, video game. All right, cool. Excellent. So, the last thing that I want to do is I want to tell it that white means destruction and black means safe, right? So black is going to be the regular material, and white is like, no, you've burned through this area. Okay, so to do that, I need to go back to my material here, and instead of just setting this as the color, I'm going to do that same thing that we've done a bunch of other times today, which is use a blend material attributes. And I have a material function that I already made that is just a charred ground looking material. If I can find the right thing. There it is. And all I wanted to do is say, hey, whenever it's like normally be this, but whenever it's a charred ground, be this. I'm just going to quickly grab some UV coordinates because I set this up to take some UV coordinates in that would scale it so the charred ground looked a little cooler. The other thing I built into my charred ground is a lava height value. And what I intended on doing was anytime a value is from 0 to 0.5, we blend into the destruction. And anytime a value is 0.5 to 1, we raise the lava height. So to do that's pretty straightforward, because if you multiply a value between 0 and 1 by 2, it's now between 0 and 2. And any value that was previously 0.5 is now equal to 1. So if I just times this by 2, but clamp it so nothing goes above 1, that's going to be my blend into being lava. And if you follow that exact same logic, but subtract 0.5, you now have a value between negative 0.5 and 0.5. If you times that by 2, you now have a value between negative 1 and 1. If you clamp that, you now have a value between 0 and 1. Again, this was more about showing you the concepts behind some of the stuff that I'm doing and letting you know what is possible than a crash course in math. Cool. So with that done, I'm going to click apply. Give it just a second. Go. I feel like we need to play like Chariots of Fire or something, but like a copyright acceptable version of Chariots of Fire. All right, so let's play this. Can I get my laser? And if I move it, we're now painting destruction behind me. Very grassy destruction, unfortunately, right now. Cool. And one of the cool things with this is if I bring it close to more lava, notice that the lava like seeps into each other and then connects. This is some abstract art right now. If you're ever wondering what art at the end of the world looks like, it's probably got something to do with one of these giant lasers. All right. Cool. And you know, if I look down what we've got here, we have this kind of like, as I said, it's blackening the ground. So that 0 to 0.5 range is doing this. And then my 0.5 to 1 range is just going all the way lava. Which kind of creates that nice little effect. The biggest problem I have right now, which is rather embarrassing, is this one. Which totally destroys any of the cool factor involved in my lava. All right. So there's a couple of ways that I can handle this. And honestly, the quickest and dirtiest solution here is straight up to just open the grass material And like this is a huge material, but honestly we don't have to actually care about most of it, so I'm just going to do this up here and hope that no one judges me for it. But if I was to get the current opacity mask value, and now this is currently white where there's destruction and black where there's not. If I flip that upside down, it's now, instead of going black to white, it's going white to black. I'm just going to plug this in. Recompiling the grass. Actually, while it's doing that, I'm just going to do it to the flowers as well. Flowers aren't called flowers, they're called heathering. I shouldn't have made that "we got the power" joke, because right now in the back of my mind as I do this last bit, all I can think of is that song from the opening video. Cool, give that a second to compile. And I'm going to enable grass on this view mode. Show me grass. Here's a cool part. See that grass there? As the laser approaches this, it's going to burn away the grass. So watch this. If I was to select my laser and I was to run this all again, G. So it's actually kind of burning away the grass that's there. See that? Touch the lightning. That's what does that even mean? Ta-da! Video games. Yeah. That pretty much does it. Yeah, of course, I have the power. Okay, cool. So that's so this is about to turn into a pun thread, so I'm going to avoid the YouTube chat. That's the last of what I've got. The question was, shouldn't the grass emit smoke? I mean, I could, but I won't, because I already showed people how to do volumetric fog earlier today in the other lesson, so I feel like we've covered that. You would just spawn volumetric fog around the bottom of this thing. So question here is, can you burn the buildings? This won't do anything to the buildings because I've literally told it to only paint the landscape right now, but telling the buildings to support burn wouldn't be that hard. We actually have a really cool thing built into Unreal Engine now called Chaos Physics. Chaos Physics allows you to run full-scale physical destruction. Hey Alex, if you're on the line, do you mind copying in the Chaos Destruction demo?
On it.
Thanks, man. We have a really cool Chaos Physics destruction system that's it's really cool. You can just kind of, actually I think I have a video of it somewhere here that I can just pop on screen now that I think about it. I mean, still get the full reel because it's really cool. But, I had one. All right, Alex beat me. Cool. So Alex has got he's copied that in. So yeah, we have a full chaos destruction system. So like realistically, I could be using that and just applying impulses to this and just blowing up the building. Could you use chaos to roughen the edge of your laser burn, or is that overkill? Yeah. I mean, that would be actually that's a really great idea, which honestly I probably should have thought of. But I mean, to do something like that, all you would need to do would be to subtract on your brush some sort of noise. Oh, you could multiply it. Yeah, let's multiply it. I think this will work. And I would need noise. And noise is going to be a 0 to 1 position. This requests a This requests a 3-dimensional coordinate, not a 2-dimensional coordinate, so I'm just slap a 0 on that thing. Which should give me that, and now I just need to have the correct number of tiling, so... Sorry folks, this is what happens. 20 seems good, and let's make this go between 0.2 and 1. Which should give me some dark lines running through these. Alright, let's see what that looks like. Is that built? Yeah, that's built. Play. Oh wow, that was way cooler. I totally should have done that from the start. Now you get that nice little, like, not immediately circular look. Oh, I regret everything. Why have I wasted my life? Alright, let's... I mean, now you've got me started on this, so... I could bring this down to like 0.5, I guess. So, all I'm doing is just adding some noise into that initial laser. It'll still end up circular eventually. Yeah, okay, that's way cooler. And I've given this demo quite a few times, so well done on now making me feel bad about that. I kid, this is legit great. Oh, I should have done that every time. What a fool. Alright, great. Clearly Luke has built a giant death laser or two before. I'm guessing no comment. Okay, so that was it for the technical art session. I know this was a weird one. Like I'm fully understanding that this was a weird one, but I really wanted to do something that was not what you're probably going to find in your average YouTube video. I wanted to show something that was very much like what an advanced user could potentially create, and to get that ball rolling. Because the truth is that anyone here that is submitting for this project, you know, you might have a nice, perfect little contained story that doesn't need an ounce of what I touched on today. And that's great. And like, legit, that is still excellent. But you may have also been like, you know, I really wish I could have set the world on fire, or I really wish a volcano could be going off, or, hey, funny thing, Chris, I'm glad you brought up that giant death laser. You know, like, I don't know what people are creating here. So, I wanted folks to look at this and not just think to themselves, well, there's no solution on the marketplace. So, damn. I really wanted folks to kind of just understand that a lot of these real-time systems and a lot of these shader setups give us a lot of maneuverability in what we can create. And I hope this was effective in conveying that this evening. Now I'm going to switch over to the last formal Q&A that we're going to have with the team just before I guess before everyone goes back to their sessions and such. For some reason Tony's video isn't playing on my end. One moment. Is Tony around? Well,
should be. He
okay.
only just replied to call.
Interesting. All right. Awkward. But I'm sure he'll come back.
Yeah.
Thanks. Oh, okay. Now I've turned off his screen. All right. Nope. Now it's old Tony. All right. Misclick. We're 47 sessions in. Still don't know how to use Discord. All right. Yeah. Woo! We're through. That was it. Last session. Congratulations, everybody. We made it. Unless, of course, you're like watching these out of order, and you're coming back to these after the fact, and this is 3 days from now. At which point, damn. So, congratulations, everyone. We're through. It's time for some Q&A. Just as a refresher, again, if you got any low-level questions, low-level meaning like overly complicated, not low. Oh, yeah. Anyway, then Alex is the guy for that. if you have anything on the art or the technical art side of things, that's going to be me. And if you have anything regarding the overall project itself and like the challenge itself, sorry, then that's going to be Tony. So, if you have any questions, yeah, by all means, hit away now. Whew. Sorry, this last one was definitely good that it was the last one. I'm a little tired.
You're done good. You're done very
So yeah, you can, if you have any questions as well, and you are actually watching this after the fact, it is worth noting, you can hit up that email address that we've set up, which is just sfc-anz at epicgames.com. If you have any questions about how to achieve certain things, then, again, feel free to put them through now. There's a couple of questions popping up. If we're moving states soon, will there be a problem with which state we should apply for? Oh, wow.
Probably. Typically what's going to happen is your screen agency, again, this is going to be determined by whether you apply as an individual or it's a company, but it's where you're registered. So even if you're applying as an individual, presumably you're going to have an ABN to your name. It's where that's held. So yeah, probably check in with screen agency.
Yeah, you might be able to talk to them, and if you already know some of the members that are in the state that you're moving to, potentially they could be the lead on the project while you're in that like awkward other in-between area. But you'll need to just chat to the agency you're going to about the situation that you're in, and hopefully they can get you over that line.
And if you are moving to or from Melbourne, well, you're not. It's still Victoria.
Yeah. I think doing a PhD on virtual production next year. Do you know if Unreal Engine supports education and university stuff at all? Yeah, 100%. So when it comes to that side of things, Unreal is completely free. It's completely free for any educational use. And I mean, even if you release something through Unreal, we only really charge when it's if you're selling a binary. So if you're doing a film and it's just linear images coming out of UE, there's no cost associated with the license on that regard. So yeah, I mean, if you're doing a PhD on virtual production, you'd be all set. In fact, if you're going down that pathway, please feel free to reach out to us, because like if you're looking at doing it next year, by the time you get going on that, virtual production now versus virtual production a year ago is already a different beast. It's accelerated like no one's business. And a year from now, it's going to be an even more exciting place. So if you want to have a conversation with the team about like what your PhD is, and whether there's any advice or direction or anything like that, I'm more than happy to have conversations like that. You can hit up the initial email and we'll follow on with you from there. It's really nice to see everyone's thank yous and such in the thread. That's very much appreciated from this end. So what other questions do we have that are coming through?
Connor, I'm just going to jump in super quickly. SA and Northern Territory agencies have very, very good relationships. So SAFC and Screen Territory are very, very close. You should definitely have a word with them.
Are successful projects based on narrative or Unreal innovation? I mean, I'd say it was neither. It's really about what the final product is overall, right? I mean, how would you cover this one too?
Yeah, it's really based on the creativity of the project. It could be the narrative, which is extraordinary. It's unlikely to be based on really in any serious form on the Unreal innovation. We don't have that expectation of you. This was just an opportunity to flex a creative muscle. So that's what we'll go with.
Yeah. And I mean, like, it's worth noting that, you could have a very clean, simple, like toon style project. You could have something that looks like it was sketched. And you could have something that looks hyper real. I mean, like, all of those things are just art styles that are achievable. So it's up to you how you kind of approach that side of things on the Unreal side. Excuse me. I've had the hiccups this entire presentation. It's just like, it's driving me mad. I haven't been able to shake them. If you've downloaded main, Luke, there's a chance that the water tools aren't in main yet. I'm not sure because we haven't branched officially to 426. So what you have right now isn't 426. What you have right now is main. I know the volumetric clouds are in main right now, but I'm not sure if the water stuff is. Unfortunately, you may need to hold off on that one just a little bit. What are the general thoughts on marketplace tools for things like procedural cities and simple crowds? So that's a really great question. There are some pretty solid marketplace tools. I haven't fooled around with any of those myself, but I mean, for what it's worth, if your project gets approved, and you've got 20,000. It's probably a minimal expense to investigate one or two of those. Just kind of pick your battles between which of those things you think was going to be the biggest investment of your time and which one's going to save things. Have you seen any procedural city stuff yourself, Alex, by any chance?
I vaguely remember some facade generation plugin, but I can't remember what it was called.
Yeah. Can you recommend a way to do fluids in Unreal Engine? So, funny story. One of the things that you can use Niagara for is fluid simulations. And Asha, one of the technical artists at Epic, recently demonstrated this. And I think this is using the build that's in main. Why is everyone requesting... everyone's requesting features that are about to come out. Asha did this. Wait for it. Here. Wait for it. Play.
That internet.
Yeah, sorry. He actually wrote a fluid solver using Niagara, which is this. So there is some cool stuff. So if you look at what it's doing, it's basically filling it up with those balls. Or GAC, I guess. There is some really, really cool stuff that's kind of coming in on that regard. Yeah. Cool. I'll switch back to the Q&A. Sorry. Ash is well worth following as well. He's a good dude. It's Vuthric on Twitter. Are there any issues using plugins such as Yeti or Heifer? No, nothing like that. If you're going to approach the hair and fur solutions, you may want to just check out the groom that we have built in. It's pretty good. It uses Niagara to the hood. Do you mind copying in a link to Ash's? I made the awkward thing tonight of signing into the YouTube chat with my non-Epic Games account. So I'm signed in on my personal account, so I haven't been commenting on the chat. Thanks for that, Alex. Much appreciated. So what are the other questions that are coming through? Cool. It looks like that's it for the core questions. Great. Cool. Sorry, I just did a quick scroll up to make sure I didn't miss anything. Cool. Well, in that case, look, once again, as far as closing words are concerned, thank you very much. I'm super excited to see what you've got. Any words from you, Tony?
No, I mean, again, I want to thank the two of you for a massive effort. I know how hard this was and really, really appreciate it. And for everybody that attended, thank you. Obviously, we hope you got a lot out of it. We're really keen to see what you come up with. And we're always around. So you have an email for us. We're here to help all the time. Just ping us when you need us.
Yeah, we are around, and right up until the point that you're pitching, if you're looking to get any sanity checks on some of these projects and say, hey, is this actually doable, or should I be cutting scope? Let us know. And for anyone that is accepted, let us know about if the moment you think you may have gotten in too deep, and what we can help to kind of drain some of that water as well. So keep us in the loop either way. But for what it's worth, I'm really excited to see all the applications. And the final thing as well is, if you are doing art tests leading up to the pitch as well, I've seen a bunch of people posting things in Discord, but if you want feedback on some of the stuff that you're doing and just some technical pointers about hey, what can I do for this scene to kind of go to the next level? What kind of effects could I add in? What references do you have for whatever it is that I'm doing? Feel free to reach out, and we'll do our best to get back to everybody as we go along. But otherwise, good luck to everybody here, and have a good night.
Take care.
Cool. Thanks, folks.
Tell me, is this thing on now? I've been working long like a marathon now. Tying up words, making them a ball now.